What if losing an arm or a leg didn't have to be permanent? What if doctors could help the body grow it back, not using machines or metal, but using our own cells? Every year, millions of people lose body parts from accidents, war, or disease. Right now, we can only replace them with artificial limbs or transplants. But some animals already know how to do something we can only dream of. They can rebuild what's lost, completely. If we can learn how they do it, we might one day change how humans heal forever. The salamander is one of those animals. It looks simple, but what it can do is truly special. When a salamander loses a leg, it grows a new one. If its tail is bitten off, it grows it back. Even if parts of its heart or eyes are damaged, they can regrow too. When a human gets hurt, the body reacts by forming a scar. The scar acts like a quick patch that stops bleeding and infection. It helps us survive, but it also blocks real repair. The damaged area becomes sealed. It's strong, but it doesn't work like the original tissue. A salamander's body reacts very differently. When it is injured, the cells near the wound don't turn into a scar. They go backward, becoming soft and flexible again. These cells forget what they used to be. A skin cell stops being a skin cell. A muscle cell stops being a muscle cell. They become blank, ready to turn into whatever the body needs. All these flexible cells gather at the wound and form a small bump called a blastema. This is the key to regeneration. Inside that bump, the body starts to rebuild everything that was lost. The cells communicate with each other through tiny chemical signals. Some become bone, others become muscle or skin. Slowly, piece by piece, a new limb grows. It takes time, but in the end, it works and looks just like the original. Scientists have found that special genes help make this happen. These genes, called MSX1, PROD1 and NAG, tell the cells what to do and when to do it. They're like tiny instruction manuals for rebuilding. Using special microscopes, researchers have watched these genes turn on and off while the salamander grows a new limb. It's like watching life write itself again from scratch. What makes this even more interesting is that humans also have many of the same genes. They're just quiet. A long time ago, early humans could probably regenerate better than we can now. But as our bodies evolved, we developed faster ways to heal wounds. Our immune systems learned to close cuts quickly so we wouldn't bleed or get infections. That quick healing saved lives, but it also meant losing the ability to regrow. Even so, there are still signs that the human body remembers a little of that old skill. The liver, for example, can regrow most of itself if part of it is removed. The skin constantly renews. The stomach lining replaces itself every few days. And in young children, the tips of fingers can sometimes grow back if the injury is clean enough. This shows that the body still knows how to rebuild. It just doesn't always know when to use that knowledge. The main reason humans can't regrow full limbs is because of scar tissue. When we get hurt, our body moves fast to close the wound, but that quick fix traps the cells and stops them from forming complex parts like nerves and bones. Salamanders don't have this problem. They heal slowly and carefully. Their cells stay flexible until the new part is finished. Right now, scientists are trying to find ways to help humans heal more like salamanders. In many labs, researchers are testing molecules that can wake up our sleeping regenerative genes. Some studies focus on teaching cells how to go back to their flexible early state. Others look for ways to stop scars from forming in the first place. The results are small but promising. In some mouse experiments, damaged muscles have regrown. In others, nerves have started to reconnect. Scientists have also learned a lot from studying the axolotl, a close relative of the salamander that can regrow its limbs many times throughout its life. By watching how it heals, they are slowly learning which signals control the process. Technology is also playing a big role. 3D bioprinting allows scientists to print living cells in layers to create pieces of real tissue. In some experiments, doctors use tiny sponge-like structures called scaffolds that are placed inside wounds. These scaffolds help guide new cells to grow in the right shape. It gives the body a clear path to follow while it repairs itself. Stem cell research is another major step. Stem cells are special because they can turn into any type of cell the body needs. Scientists are learning how to turn regular adult cells back into stem cells. This means that one day a patient's own skin cells could be turned into bone or muscle and used to rebuild what was lost. Gene editing tools like CRISPR are helping too. CRISPR lets scientists change small parts of DNA with great accuracy. By turning certain genes on or off, they can test which ones control regeneration. The goal is to understand how to restart the body's natural repair process without causing harm. This kind of research needs to move slowly because regeneration is powerful but risky. The same process that allows new cells to grow can also lead to cancer if it goes out of control. Cancer and regeneration are very similar in one way. Both involve rapid cell growth. The difference is that regeneration is organized, while cancer is chaotic. Salamanders somehow control this balance perfectly. Learning how they do that could be one of the biggest medical breakthroughs of all time. But as we get closer to understanding regeneration, we also need to start asking deeper questions. If humans could regrow body parts, who would have access to it? Would it be free for everyone or only for the rich? Would people use it only to heal or to make their bodies stronger or younger? And how would this change how we think about aging, death, and being human? These questions show that regeneration is not just a scientific problem, it's also an ethical one. Still, progress keeps moving forward. Many scientists believe that in the next few decades we will be able to regrow simple body parts like skin, cartilage, or parts of muscles. Hospitals are already testing regenerative treatments for severe burns, heart damage, and nerve injuries. Some patients have even received skin grown from their own cells. These early results are small steps toward a much larger goal. The future of regeneration is not only about rebuilding limbs, it's about teaching the body to repair itself completely. If we can learn how to control that process, it could help people recover from aging, organ failure, and diseases that were once seen as permanent. It could mean a world where healing is not about replacing what is broken, but renewing it from within. Every person knows what it feels like to lose something, whether it's health, ability, or time. The idea that life can rebuild itself gives us hope. It reminds us that change and repair are part of nature, not the opposite of it. We can see that truth everywhere. Forests grow back after fires, rivers carve new paths after floods, even stars that die in space release the materials that make new stars and planets. The universe itself is built on regeneration. Nothing is ever truly gone. It only changes form and starts again. Salamanders are a small part of that bigger pattern. Their bodies show what life can do when it stays open to change instead of closing with scars. If humans can learn that same lesson, we might one day see healing in a completely new way. Maybe regeneration isn't just about growing back what is lost. Maybe it's about remembering that life always finds a way to begin again. Every cell in our body already holds that secret. We just have to remember how to use it. Do you think we can regrow limbs like salamanders one day in the future? Comment your thoughts down below and don't forget to like and subscribe while you're there.